Hello friends, today's topic of discussion is evaluation of a prefix expression. So we have already evaluated a postfix expression in our earlier video, but in this video we are going to discuss about the evaluation of a prefix expression. As you know already that what is a prefix expression? That is an expression where the operators precede the operands is called a prefix expression. A simple example can be like this. Suppose a plus b is the normal way to write any operation where this is an operand, this is an operand and this is an operator. So this expression is always called an infix expression. And what is a prefix expression? Prefix expression is nothing but when the operator comes before the operands, then the expression is turned into a prefix expression. So suppose this plus is written here and followed by AB. So this expression becomes a prefix expression. So this prefix expression, if any prefix expression is given in terms of numbers and operators, we can evaluate the prefix expression. So what is the algorithm or what is the algorithm which we can apply to evaluate the prefix expression will be now discussed in this video. So let's get started with an example expression which is obviously a prefix expression, and we will try to determine the value of the prefix expression. So let me write the problem first and then do the solution to the problem. Suppose our input is a prefix expression. Suppose this is a prefix expression, example minus, plus, 2, star, 3, 4, 8. So this is a prefix expression where I have written minus, plus, 2, star, 3, 4, 8. So you can easily see that the operators are preceding the operands. The operator is preceding the operands. So this expression is obviously a prefix expression, and we will try and determine the value of this prefix expression, and that is nothing but the evaluation of this prefix expression. So first of all, we need to do is to put a closing parenthesis. First of all, we need to just revert the expression beginning. The input is suppose a prefix expression, we call it P, and now we will reverse. I will just reverse the prefix expression into expression which can be called as P dashed. Suppose the expression will be reversed to write like this: 8, 4, 3. Just in the reverse order I am writing 8, 4, 3 star 2 plus minus. Now after reversing the entire expression laterally, we get this expression which is now going to help us to determine the value of the original prefix expression. So now what is to do is to insert a closing parenthesis at the end of this reverted expression or inverted expression, laterally inverted expression, and then follow a similar approach which we have followed in the case of evaluation of a postfix expression, except for one operation which we will discuss in a bit. Then you will get to understand what is the difference in that operation. So let me just start running the algorithm and trying to find the value of this expression. So we will write like this. It is nothing but another example of another implementation of stack. So it is an implementation of the stack data structure. So this is a application or implementation of, rather you can also write application. application or implementation of the stack data structure. So we'll write like this: symbol scanned, we'll write in a tabular form, symbol scanned, and in this right hand portion I will write stack. First operation, step 1 will be, we will always scan from left to right like this. So first we will scan 8. So symbol scanned is 8. Since it is an operand, our rule in the algorithm is that if it is an operand, it has to be pushed onto the stack. We will write the stack in this left to right manner, and you will consider the rightmost element to be the topmost element of the stack. So 8, since it is an operand, we will push that operand into the stack, and the stack looks like this. Now stack has only one element, which is the 8, and this is the only element, solitary element in the stack, which is the topmost element now. Now after that we scan this second expression, that is the second element, that is the 4, second character rather, that is the 4, and 4 is also an operand. So we'll again push the 4 onto the stack, and the stack grows and becomes like this. 8, above 8 is 4. The topmost element is now 4, and the next to top element is the element 8. 3. Number 3 step, we will scan 3. 3 is also an operand. Again we push 3 onto the stack. So now the topmost element of the stack is 3. The stack grows in size. In these 3 steps. That is, previously the stack was empty, and after that the stack length was 1, then 2, then 3 now at this stage. After that we scan this asterisk. That is the multiplication sign. So star is nothing but an operator. When we find an operator, when we encounter an operator in the expression, our work is to pop the top 2 elements, that is the top element and the next to top element, and perform an operation which is just in the reverse way, as we have done in the case of evaluation of the postfix expression. That is, in that case our top element was called A, we will call it A here as well. We will think the next to top element as B. Our operation in the evaluation of postfix expression was B operator A. What was done in that case? B operator A. But in this case, in the evaluation of the prefix expression, we will just follow the reverse approach, that is we will follow A operator B. So here in this case, star is our operator and A is this topmost element and next to top element is 4, and we will perform the A is what? 3. We will perform the multiplication operation in this way, 3 star 4, and whatever is the result, we will push again that result back to the stack. 8, 12. Now 5. Number 5 step, we encounter an operand once again, that is 2. So we will push this 2 onto the stack. The stack is now containing 8, 12 followed by 2. 6. Number 6, we encounter another operator, that is plus. And again our work is to perform the operation A operator B. So this is A now and this is B now, and we will perform the operation A operator B where the operator is plus. A is 2, operator is plus, and B is 12. 2 plus 12 is equal to 14. So we will push the 14 back onto the stack to get the stack in this manner, 8 followed by 14. So the topmost element is now 14. After 6, the number 7 step, in the number 7 step we see that we are encountering a negative sign, a subtraction symbol, and that symbol is definitely an operator. And since it is an operator, our work is similar to this step. That is, we will call this top element as A and this as B and perform the operation as we have done in the previous step, that is A operator B. Our operator is minus and we will perform the operation like this: 14 minus A operator B means 14 minus B is 8. So 14 minus 8 is 6, and we will push the result back onto the stack, and correspondingly the stack contain in this number 7 step, the stack looks like this. Now after that we encounter the closing parenthesis or the right parenthesis, and as soon as we encounter the right parenthesis, we exit the algorithm, and there is a value, there is a variable called value in which we will pop the solitary element, that is the topmost element here, and which is the 6, and put this element and assign that element into the variable value, and this value will contain now 6, and the stack becomes empty. We will exit from the algorithm in this step, and our work is now done with, and whatever is the value of the variable value, that is 6 in this case, is going to be the answer to our problem. That is, our original problem was minus plus 2 star 348. This was a prefix expression, and the value of that prefix expression is now determined to be 6. So we have done the evaluation of the prefix expression in this manner, and if you have any doubts and queries pertaining to this example, you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.